All right, hi everybody. This video is for Ms. Fawn's pre-algebra class. This is a review for your first quiz of chapter 2. So I'm going to go ahead and share my screen. You guys should have your review guide in front of you. Hopefully you've had a chance to work on it and have anything you've done in front of you, and we're going to work through the problems together. So let me go ahead and share the screen with my copy of that document. There we go. Okay, so the first part of this, you're going to have some questions somewhat similar to this. They're going to give you a situation, and you're going to need to be able to explain whether it's closed or not closed. So remember, if a set is closed, that means that the two numbers added or multiplied together equal a sum or product that exists in the same set that the problem has given you. So if it's an integer, that means that as long as the answer is positive, negative, or zero whole numbers, then it is an integer. If it's asking for just positive or just even, you need to kind of work through some of those and see if anything proves that statement false. So let's go ahead and start off here. So some of these we did in class where we're asked, is the set of 0 and 1 closed for addition? So if you remember when we did this together, the answer here was no, because I missed it the first time. But that's because when you add 1 plus 1, you get an answer 2, and 2 is not in the set of 0 and 1. So therefore, the set is not closed because the sum of 1 plus 1 is outside of the set. Okay, how about is the set of positive even integers closed for addition? Now in this case, let's look at two positive even integers. And we know that, say, 2 plus 2 equals 4. But we also know that anytime you add positive numbers, that you are going to get a positive number. So any positive even integer plus any positive even integer equals another positive even integer. So let's see, plus a positive even integer equals another positive even integer. So the answer to this is yes. It is closed. All right, is the set of 0 and 1 closed for multiplication? Now, if you think about it, 0 times 0 is 0. That's in there. 0 times 1 is still 0 because we're multiplying. 1 times 0, also 0. And 1 times 1 is 1. And you're multiplying. So in this case, with multiplication, the set 0 and 1 is closed for multiplication. So I'm just going to, just so you guys can see what I've already said. So yes, 1 times 1 equals 1. Therefore, this is a closed set for multiplication. And I am not recording, am I? Did not. Oh, good, I am recording. Thought I wasn't. Let's see. Okay. So tired. Okay, is the set of negative integers closed for multiplication? So again, let's look at an example, something simple. If we did negative 2 times negative 2, what's our answer? A negative times a negative is a positive. Therefore, any negative integer times another negative integer will always equal a positive integer. So yes, this is, so no, this is not a closed set because multiplying a negative times a negative gives you a positive, which is outside our communicated set of negative integers. Okay, so hopefully that's clear to you. This should cover anything that you need to know in your quiz, but it also helps you kind of understand how the integers work together and whether they're part of a closed set. Okay, so identify the property illustrated by the equation. So again, we've been doing this a lot in our homework and classwork assignments, so it's understandable you're going to see this on the quiz. So remember, you have properties of addition and properties of multiplication. You need to make sure you specify that in your answers on the quiz. So let's look at number 5. We have 9 plus a negative 3x plus 7. And then that equals 9 plus negative 3x plus 7. So in this case, everything is in the same order on each side of the equation, but we've changed our order of operation. So this means this is an associative property of addition. Specify addition. All right, in the second one, we have 12 times 4 equals 48, and 48 is an integer. So what it's giving us is the definition of a set, so integers. So this is the closed property of multiplication. Okay, so the next one, 12 plus 7 plus 9 is equal to 7 plus negative 12 plus 9. So again, in this case, we've kept our order of operation. We've just switched around our integers. So we are seeing an example of the commutative property of addition. Now, number 3, we have 3 times 8 times 0. So we know that 8 times 0 is 0. 0 times 3 is 0. So surely you figured out by now, this is the 0 property of multiplication, which we call the inverse property in addition, always equals 0. Okay, so in number 9, we have x times negative 5 times 4 equals negative 5x times 4. So this one can be a little bit confusing. You may think that this is actually the commutative property. What it's actually showing us is it's changing our order of operation, because you would never have x minus 5, x times minus 5. You would always put the constant in front of the variable. So this isn't exactly changing our order of operation, or excuse me, it's not a commutative. This is an associative, because it is changing the order of operation. When you have negative 5x times 4, then what you're actually saying is you need to multiply negative 5 times x first, and then that you need to multiply times 4. So this is an associative property of multiplication. All right, and then can everybody see what's going on here in number 10? We have a multiplication problem that looks very complicated, but it equals 0 because there's a 0 stuck in there. So 0 property of multiplication. Those are pretty easy to recognize as long as you know what you're looking for. So if you're comfortable with these examples, then you're in good shape for the quiz. If not, then let me know, and we'll see what else we can do to work one-on-one with some additional problems. Okay, so you're also going to be asked to simplify. Again, you're using your properties of addition and multiplication to simplify these. So in this case, for number 11, first you want to perform your order of operation, which tells us that negative 9 plus 3. So 2a times negative 9 plus 3, that gives us a negative 6. Then you're going to want to use a commutative property to put like with like. So we have negative 6 times 2a. So this is our commutative of multiplication. And then you just multiply negative 6 times 2, which is negative 12a. And that's our answer. All right. So next one. We have 4x minus 3y plus 2x minus 5y. So in this one, we first use the commutative property to group like with like. So we change this to 4x plus 2x minus 3y minus 5y. Commutative property of addition. All right, so then we just add those together. Excuse me, there we go. So 4 plus 2x plus negative 3 minus 5y. All right, and that gives us 6x minus negative 3 plus a negative 5 is a negative 8, so that's minus 8y. 6x minus 8y is our simplification. Can't get any more simple than that. All right, so lastly, we have negative 7b times 2a times negative 3. So again, I would use the commutative property to group my constants and my variables separately. So negative 7, 2, and negative 3 times a and b, since we don't know those. So let's go ahead and solve our constants. Negative 7 times 2 is 14 times negative 3 is, I believe, 52. So 52AB, and that's our answer. Okay. All right. And then we have to solve for x. Now, in this case, this is also very similar to what you're going to see on your quiz. You need to just recognize how your properties of addition and multiplication allow you to solve for x. So when you look at 2 plus x equals 10 plus 2, what we see here is an example of the commutative property of addition. And so when you plug in your known value on the right, the 10, that is your answer to the value of x. So if 2 plus x equals 12, then x equals 10. Sort of another way to put that. Okay. Now again, we see something a little more complicated, but don't let yourself get too intimidated by all these variables. Just look at what you're needing to solve. You're solving for x. So if you look here, you have x plus 18. And then over here, you have 3 plus 18. So in this one, I can say that if x plus 18 equals 3 plus 18, then x equals 3. All right, last but not least, we have a case of multiplication. So we have 3 times x plus 9 is equal to 6 plus 9. So what that's telling us is we're solving 3x. So you use the associative property, and you can say that if 3 times x equals 6, then x equals 2. All right, this is the associative property. So you can see how we've changed our order of operation here. When you see the 6 plus 9, that means that what you've done here is you've done 3 times 2 first plus 9. And so then you're able to determine that the value of x is 2. Okay. All right. So that is pretty much everything that you were going to see on your quiz is covered in this. So as long as this is familiar to you and you're comfortable with it, then I suggest you go ahead and put this aside and attempt your quiz over sections 2.1 and 2.2 of your pre-algebra. Once that's done, make sure you put it back in your folder so that you can bring it to me on Monday to grade. And if you have any questions before you work on your quiz, then please reach out to me via phone or email, and we will schedule a time to work together. All right, so I hope you guys have a great rest of the week, and I'll talk to you again soon. Thanks.